Hey guys, so today we're going to look at the graphs of f of x and what the graph of its derivative looks like. Eventually we're going to start looking at higher order derivatives, but I want to look at this first. So it says find all the critical values of f of x. Remember, that's going to be the turning points of f of x. So what we do here is we find the derivative. F prime of x is 2x. Set the derivative equal to 0 and solve, and you get x equals 0. So that's just a little reminder how we find critical values. Okay, so now let's take a look here. Over the interval from 0 to 4, first off, I don't know why the graph keeps going. It's supposed to stop right here. From 0 to 4, so it's also supposed to stop right here. F of x equals x squared minus 4x plus 5. Nice parabola, right? Downward facing parabola. And what is the derivative then? Well, the derivative is 2x minus 4, and here's the graph 2x minus 4. It's linear. It's got a slope of 2 over 1. It's got a y-intercept of negative 4, and there it is. Now, what are my critical values? Well, let's set the derivative equal to 0, and we solve, and we get 2x equals 4, so x equals 2. So our critical value is 2. Now, what is our next step generally for the first derivative test? We plug in a value to the left and to the right and see if we get a negative or a positive number. Right now, we're not really going to have to do that here now because look at the graph over here. I'm going to highlight something. Anytime you plug in a number here, right, any y value here is going to be negative. So to the left of negative 2, if you plug in 1, sorry, positive 2, if you plug in 1 or you plug in 0, what's going to happen? You're going to get a negative number. But what happens if you plug in a number to the right of 2? You're going to get a positive number. So that's telling us that the graph is going down and then up, so we get a minimum. So what this lesson is teaching us is you can look at the graph of a derivative and tell its location above or below the x-axis. When you plug in, will you get a positive y or a negative y? Now, our intervals, where is f of x increasing? Well, it's increasing from 2 to 4, including 4 because it's a closed interval. At 4, it's still increasing. And decreasing from 0, including 0, to 2. At 2, what is happening? It's neither increasing nor decreasing. The slope of the tangent line is 0. Okay? Now, what about relative max or mins? Well, relative min for sure, an absolute min, right? At x equals 2. We could plug in and find what y is, but there's no need. I just wanted to locate this minimum point right here. So let's take a look at some other functions and its derivative graph. Find all critical values, relative extrema and absolute extrema between negative 1 and 1. So your function here is 3x cubed minus 3, so your derivative is 9x squared. Right, the constant doesn't matter. So set the derivative equal to 0, and you get x equals 0. Let's do our first derivative test. 0. Okay. Now, if we plugged in a number to the left of 0, look at the derivative. Would you get positive y or negative y values? Positive. What about to the right of 0? Positive. So we have positive, positive, which means, do we have a relative extrema? No, it doesn't go up to down or down to up. It's up, up. Now, this graph looks like maybe it does have relative extrema, but take a look closely at 3x cubed minus 3. When the slope is 0, right here, it goes from increasing, all of these slopes are increasing, to still increasing. It's not decreasing. So, and we can see that here because the derivative 9x squared has all positive values. The slope of every tangent line is going to be positive. So no relative extrema. Okay. When is it increasing or decreasing? It's increasing the whole interval from -1 to 1, which is what they want us to look at. Decreasing? Never. It's going up, 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 up. Number 3. Find all critical values, relative, extrema, and absolute. Let's try another here. So we got, okay, let's take a look. 4x cubed minus 24x plus 18. So the derivative is 12x squared minus 24. And here is the graph of 12x squared minus 24. Let's find our critical values. So we get 12x squared equals 24, x squared equals 2. You get x equals plus or minus rad 2. Okay? Now, this plus or minus rad 2, right? What does that plus or minus rad 2 represent? Well, remember, when you set a function or an equation equal to 0 and solve, you're finding the roots. So these 2 points right here is going to be rad 2, negative rad 2. So we can use that to help us with our first derivative test. So we got endpoint says from -5 to 5, and then we got negative rad 2 and rad 2. And take a look. To the left of negative rad 2, are the y values positive or negative? Positive. And then to the right of negative rad 2, it's negative in between the whole time. The y values, when you plug in, you would get negative y values. And then after that, positive. So that means increasing, decreasing, increasing. That means at negative rad 2, we're going to have a max. And at positive rad 2, we're going to have a min. Let's take a look at our original graph and see if that matches. Negative rad 2, max. Positive rad 2, min. Right? That's also going to tell us what these values are. This is rad 2. And then somewhere over here is negative rad 2. All right. Let's take a look at the last one, and then we'll sum it up and we'll be done. Oh, sorry. Hold on. Let me write some stuff down here. So you have a relative min at x equals rad 2, relative max at x equals negative rad 2. It's increasing. When is it increasing? It's increasing from -5 to negative rad 2 and from rad 2 to 5. And it's decreasing from negative rad 2 to rad 2. Last one, 3x to the 4th plus 12x. That makes our derivative 12x cubed plus 12. But we're looking at this between -2 and 3. Right? So set 12x cubed plus 12 equal to 0. Take a GCF out of 12. You get x cubed plus 1 equals 0. You can just solve this. Subtract 1. You get x cubed equals -1. What's the cubed root of -1? Well, that is -1. So there's only one critical value, and that's why this graph, which kind of looks weird over here, I know that 12x cubed plus 12 has a lot of stuff going on, but we only need that one critical value here. So -1, and it's from -2 to 3. To the right of -1, positive numbers. To the left of -1, negative numbers. Decreasing, increasing. There is a min. So we have a relative min at x equals -1. It's decreasing, from -2 to -1, and it's increasing from -1 to 3. Okay, guys. Any questions, please remember, just send me a message or email or whatever you got to do. And yeah, have a good day.